Hi everybody, welcome to this video that I'm making for my Chem 365 coursework. It's a video where I mash up the two things that I love most in the world, which is science and makeup. So I'm going to be doing like a makeup tutorial where it's going to be like quantum chemistry related, and at the same time I'm going to be talking about quantum chemistry and electronic structure theory and just trying to explain its applications and why you should study at a university. So hopefully it's going to be a fun and informative video, and it's aimed for primarily A-level students. I'm going to have to talk about some of the science, which is it's complicated, but we'll get there. So while I'm prepping my skin with moisturizer, I will briefly introduce what quantum chemistry and electronic structure theory are. So quantum chemistry is focused primarily on the application of quantum mechanics to chemical systems. It provides an underlying framework for describing how the properties and interactions of molecules arise from the fundamental interactions of electrons and nuclei. And then electronic structure theory describes the motions of electrons in atoms or molecules. So that was a lot of big words, but essentially what we're trying to do is study atoms, atomic and molecular systems, so that we can then hopefully manipulate the properties later for applications that I'll talk about later. The foundation of quantum chemistry is the Schrödinger equation, and there are two types of Schrödinger equation. So we've got the time dependent Schrödinger equation, which looks very ugly, but essentially what it does is it gives a description of a system evolving in time. And then on the other side, which is the one that we actually care about, is a time independent Schrödinger equation, and this describes the state of a system at a particular point in time. So the product of the Schrödinger equation is a wave function, and what a wave function does is it describes an atomic or molecular system in its entirety. We can apply different things called operators to the wave function to extract systems that properties that we're interested in. For example, the H that you saw earlier is something called a Hamiltonian, which is the energy operator, and it extracts the total energy of the system. Yeah, so like I said before, the time-independent Schrödinger equation is the one that's used most commonly in electronic structure theory. Basically, you'll learn all about this in year 2. You don't really need to worry about it now. It seems complicated and really like, oh my god, there's loads of maths, and there is loads of maths, but it's not as hard as you think it is. So now time for concealer, which is used to conceal all our flaws, of which I have none. So there's many applications to electronic structure theory. One of them is being able to study the ground and excited state properties of molecules. So hopefully at this point you should know that molecules can exist in a ground state or an excited state. And then when you study the ground and excited state properties, this can then be related to absorption. Absorption spectra are able to be simulated for particular molecules, and this is very important in that the chemistry is related to UV vis spectroscopy, photovoltaics, photochemistry, biosensors, etc. So there's loads of reasons why you should study this. Like, the applications are immense. There's been a lot of research that's gone into absorption. However, emission is a little less well understood and researched, but it has just as important applications, such as LEDs, dyes, pigments, lasers, etc. And the ability to study luminescence has taken shape only recently, because there was a lack of information in being able to study excited state geometries and energies, especially for larger molecules. So there's been a lot of advances into being able to study emission properties because of this theory called time-dependent density functional theory, which most people don't understand, and I'm doing my project on it and I don't really understand it either, so don't tell my supervisor, please. But it's just a theory that helps us study molecules better, pretty much, and it's really complicated and you don't really have to understand it, but it's used in software that we use in our computational modules. So one of the reasons to study electronic structure theory is because of its important applications in science. It's really hard to talk and do this at the same time. So in my computational modules, when I've studied different molecules, we use this software called Gaussian. And if you're an A-level student, you probably haven't heard of it, but you basically can draw different molecules on it and then run calculations on these molecules, and depending on what you actually type in to calculate, what you type in the calculation and what you're calculating, you get different information in the files that you get back. So this is an example of one of the calculations, and you don't really need to know what each of these things means yet, but I can explain opt and freak, and basically it just means that when you get your files back, structure that you get back will be its optimum structure of the molecule, so the most stable structure. Freak refers to frequencies, so you'll get the frequency information back as well. And then with the frequency information, you can plot different spectra. So you can plot, usually you get infrared frequencies back, so you can plot infrared spectra. There's lots of other cool things that you can do with Gaussian too. It doesn't, you can visualize, I don't think you guys, so being an A-level student, you shouldn't know what a molecular orbital is yet, I don't think. But, so it's pretty much the electron distribution around atoms and molecules, which is a very, it's a massive oversimplification, but that's pretty much what it is. Yeah, so we can visualize the molecular orbitals for the molecule, and when you do, it's pretty cool. Like, you can change the color of the molecular orbitals and everything and get really pretty ones. So for example, this is one of the molecular orbitals for benzene that I printed out, and that's I think it's the very last one or something, but you can visualize that and change the colors and everything. So it's a very visual subject as well. It's not just theory. There is a lot of theory, but then the theory is very easily applied, which is what makes it better than a lot of other modules. The camera doesn't pick up the color very well. It's a very low quality camera on my laptop, but I'm telling you, I look very nice. And what I'm doing right now is I'm replicating one of the other molecular orbitals in benzene, which is this one, on my cheek because it's pretty. I finished my eyes off camera because it was hard. You can't really see them, but they look good. Well, I haven't actually. I just changed the colours because they weren't very nice. So I'm just doing blue and this really cool black colour. It's really cool. I can't really see it. Also, yes, this is acrylic paint. I just realised that the colours might be a little too similar to be caught on camera properly, which is really annoying. So I might add some white onto the green or the blue, make it more noticeable. My skin is going to be crying after this. Honestly, the effort I put in. Okay, so I think that shows up on camera. Can't really see that hydrogen, can you? Okay, I'm gonna finish the rest of the makeup off camera and then I will come back. Okay, so this is the final look. I can't even move this side of my face, it's like really stiff. But yeah, I'm happy with it. My hands are not. Hopefully that was informative and persuaded some of you guys to want to study quantum chemistry or electronic structure theory at university. It's interesting. It's hard, interesting, and definitely worth it. So yeah, bye. No, the wrong thing. And edit it out. And I have paint in my mouth, which is very nice indeed.